Well, so we have our very first assembly successfully modeled here. We have our Ed's Really Good Floor assembly with our 6 inches of XPS foam underneath the concrete floor slab. So that one is complete, and now we can turn our attention to a slightly more complex assembly. So let's shift gears and let's move on and take a look at how we're going to model our double stud wall assembly. So let's take a look at some of our example files here just to remind ourselves what it is that we're going to be building, and then we'll build out that new assembly. So I'm going to go into my example files here. So I'm just on my desktop. I've got all my example files, and I'm going to go into the drawing set just for a second, and let's take a look at what we are building. So let's just remind ourselves what we've got here. We'll just pull this in preview. And if we come down just to the floor plan, we can see we've got this really thick wall around the exterior of our building. So very common for lots of passive house buildings, a lot of insulation, very high R values if you're in a cold climate like New York State. And so no surprise here, we've got these really thick walls. And of course that's true if we go down to the section, we can see that as well, right? We've got these really thick walls that we see here in section. So what is this wall? We definitely want to model this wall assembly here. It's going to be an important piece of our overall puzzle. So let's go into our example files. And if we come in here to O3 assembly sketches and I open up the wall here in my little preview window, let's just take a look at what we're going to model. Here's our double stud wall. And as we've talked about in earlier videos, this is a very common technique for simple form passive houses. So this technique can get hard with complex shapes, but if you have a really simple shape like the one we've got here, this can be a very cost-effective technique. You build a typical in this case, 2x6 stud wall. You leave a gap, you build another 2x wall. There you go. There's your passive house envelope. Of course, it does require really good air tightness on the interior. It requires a good vented rain screen on the exterior to manage any moisture issues. We've got this air cavity or surface cavity on the interior, and then our gypsum wallboard finish as well. So a fair bit going on in this assembly. We've not only got a lot more layers this time, we have some funny layers like some of those air spaces and air gaps. And then we've got some membrane layers, and then we've got some mixed layers as well. So we have some layers here which are made of partly insulation and partly timber. So we have to sort of think about how we're going to address those layers. So definitely a more complicated assembly, but for sure we can absolutely model this inside of our PHPP. So let's shift over to our PHPP. So if you've been following along, you have a PHPP that looks something like this. I'm here in the R values worksheet. And if you've been following along, you just completed our floor assembly here. So this one is done. And so this is now part of our catalog. We have an R25-ish floor assembly as part of our catalog. And now we need to build our next assembly. So how do we do that? Do I delete all of this and then sort of build my wall assembly right here? No. The way that this works in PHPP is as you build these assemblies, this assembly is done. This assembly is now added to the catalog. And to build another assembly, I'm just going to scroll down in the scene to another assembly R value constructor. So notice we have a whole nother constructor here that looks just like the first one. Notice that it's labeled O2, user determined. And if we scroll down, we'll see a third one and a fourth one, and on and on and on. I think by default we get 50 or 60 of these constructors, so we can build up to 50 or 60 different assemblies in our PHPP catalog here. In any event, we have our floor completed, so we'll leave the floor. The floor just is done. That one's all set. And now let's get started modeling our wall in this new constructor right here. Okay, so as before, the first thing that we want to do is we want to give our assembly a name. So the very first step is to give our assembly a name. Now we can name it again whatever we feel like. I'll call this Ed's Awesome Double Stud Wall. You can name it whatever you like. I should probably spell any of this correctly. There we go. Okay, so there's our double stud wall. You can name it whatever you like, whatever works for you. I guess my recommendation would be try and keep your naming and your numbering aligned with the architect's specifications and plans. It's going to make your life a lot easier later on if those things match up. If you don't have any sort of wall tags or wall type names in your architectural drawing set that you're working off of, you feel free to make up your own. But for the most part, try and keep things consistent between your drawings. I guess that would be my recommendation. if I have one. Is this interior insulated? We talked about that last time. No, it is not. That's for retrofit projects, so this is not an interior insulation project. So that one we can just leave that blank. And then the next two pieces here we do have to fill in. So first of all, the orientation of the building element and the adjacency. So what is this? Is this a roof, a wall, or a floor? Well, it's obviously a wall, so we'll put in number 2, wall. And remember what happens here is when we put in O2 wall, the interior RSI gets designated automatically. So we don't have to put in any numbers here. We just say it's a wall, and PHPP goes off and figures out the right information for us there, which is great. Now, what about adjacency? Well, what do we have here? So this is an above grade wall. And so what is this exposed to? What it means is what's the exterior exposure? So if it's inside, if the interior is a nice warm inside, what is the outside? And we have some options here. Is the outside outdoor air? Is the outside ground? Or is the outside ventilated? What does ventilated mean? Well, we'll come back to that. We will address that in a few minutes. But for now, let's use outdoor air, right? Because this is exposed to the outdoor air. So this is just exposed to the outdoors. Okay, fine. All right, so that's all set up. Now the next thing we need to do is we just need to go through and one layer at a time, we need to build out our assembly. So we're going to have cladding and an airspace and sheathing and insulation and insulation and insulation and an airspace and gypsum board. Now why did I split up this layer into insulation? Isn't this actually just one big piece of insulation? Yes, that's true, except that the way that we're going to have to model this is we have to model, because of the mixture, because we have some timber in here, we actually have to model 2 distinct heat flow pathways. So I have one heat flow pathway that flows here through the center of the insulation, and a second heat flow pathway that flows to the timber over here. And so in our PHPP, remember we have pathway 1, we have the ability to describe pathway 1, and then we have the ability to describe pathway 2, and even up to a third pathway. If we had a third pathway, we don't. In this case, we only have a 2, so we have one here, and then a second one here. And so in order to model the second heat flow pathway correctly, we have to split our insulation into 3 layers. So that's not all that abnormal to have to sort of tackle your assemblies in multiple layers, even if in reality it's one big chunk of insulation. We split it up into layers so that we can model things correctly. So let's start with heat flow or pathway 1. So let me, just to make it obvious, right? So pathway 1 is going to be here. Oh, whoops, let me reverse that, right? So heat's going to be flowing from the warm interior to the cold exterior. Our arrow a little bigger. All right, the heat's going to flow from the warm interior to the cold exterior. This will be area or pathway 1. And then, why is that all dotted? Stop it. And then we will have our pathway 2, which will be this pathway right here. And that'll be pathway 2. So we've got 2 distinct heat flow pathways. Get rid of these silly dashed lines. Stop it. There we go. So 2 distinct heat flow pathways. We have to model both of these in our PHPP. Let's start with the heat flow pathway 1. And let's build it in our layers here the same way we see it in our image here. So it doesn't really matter what order we build the layers in, so long as we're consistent. We can go from outside to inside or inside to outside. It doesn't really matter. Let's just keep it consistent with the image here just to make our life easier. So I'm going to make a cladding layer, an airspace layer, a plywood layer, an insulation layer, insulation, 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 air, and gypsum. All right. Let me kind of pull this off to the side here so we can sort of see. Okay, so we'll come down here and let's get started. So our first one, we'll call this wood cladding. You can call it whatever you want, but let's say wood cladding. And we'll leave the R per inch we'll leave that out for now. I kind of want to see. Well, we'll just have to go back and forth. So we're told here that the wood cladding is 3/4 of an inch thick. So the wood cladding is 3/4 of an inch thick, so 0.75. So what do we have next? Well, after the wood cladding, we have this airspace, right? This is a nice vented rain screen gap, so that's the appropriate way to handle an assembly like this. Gives you good drying. good moisture management. So you got your rain screen gap there, and we are told that that gap is also 3/4 of an inch. So 3/4 of an inch there. So we've got our, we'll call this our rain screen air gap, and we'll say that that's 0.75. Whoops, that's not R per inch. Sorry about that. Pull this over here. 0.75 inches. Oh my God, stop it. Get rid of that. Thank you. There we go. And 0.75. Oh, my apologies. So we will come back and fill in those R per inches later, right? We'll deal with R per inch in a later stage. Right now, let's just fill in our thicknesses and get all of our layers organized here. Okay, so fine. All right, so what's next? So after that, we have a plywood layer. All right, so we've got our two outer layers. We now have a plywood layer, and we're told here that our plywood layer is 0.5 inches. So we'll call this plywood sheathing. And the plywood sheathing is 0.5 inches, so a ½ inch thick plywood sheathing. Now we've got 1, 2, and 3. 1, 2, 3 layers of insulation. Remember, we're going to split it up into 3 layers so that when we model heat flow pathway 2, we can mix our materials properly. So I will say 3 layers of cellulose. We'll say cellulose, cellulose, and cellulose. All right, now we're here. Now we've got our air gap layer. So we have a service cavity here. So we'll call this our air layer. Service cavity. Service cavity. And then lastly, our very last assembly, or our last material here is our gypsum board. So our gypsum board here, gypsum wall board finish. Whoops, I guess I should give all of those thicknesses, shouldn't I? All right, let's go back and do our cellulose. So our cellulose, 3 layers, 5.5 inches, 4 inches, 3.5 inches. Oh my God, drawing in this thing is not that easy. Okay, so our layers, so 5.5 inches, 4 inches, that's our next layer of cellulose. And then our last layer is a 2x4 layer, so 3.5 inches. So 5.5 inches, 4 inches, and 3.5 inches. Then our air layer, our service cavity, is 2.5 inches. And lastly, our gypsum board here is, we are told, is ½ inch, so 0.5 inches. Okay, so an 18-inch assembly overall. Notice right now it's still in an R1 because we haven't filled in any of the resistivity information here. But at the very least, we have our first heat flow pathway modeled in. So that's heat flow pathway number 1. Now what about heat flow pathway number 2? Well, we're going to model that in the next section over here. So again, let's hold off on our R per inches. So let's hold off on the resistivity. Let's just get all of our layers in here to get us started with. So, okay, what's our first layer? Well, when it comes to heat flow pathway 2, our first layer is going to be the wood cladding again. So wood cladding, and I'm just going to go through and describe heat flow pathway 2 here. And our next layer is going to be our rain screen gap again. Rain screen air gap. Air gap. It's not okay, air gap. And our next layer is plywood sheathing. So far, we're the exact same as heat flow pathway 1. But here's where things are going to get different. Notice the next layer here is a 2x6. So the next layer in our assembly here is a 2x6. We'll say 2x6 wood stud. All right, so that's that layer. Now what's the next layer? Well, the next layer right here is dense packed cellulose insulation. So cellulose. And then the next layer? Well, the next layer is a 2x4 stud. So now we have our 2x4 wood stud. And then the next layer right here, well, we're our air layer, service cavity. And then lastly, our last layer, the gypsum wall board down there. So our gypsum wall board. And there we go. There's all of our layers modeled in. So notice the main difference here. We've got these wood stud elements. These are the anomalies as compared to our heat flow pathway 1, but we've successfully modeled both heat flow pathway 1 and 2. All right. So I think we will leave this video here. We will come back in the next video and we will take a look at how we're going to fill in these R per inch values. How are we going to build out these resistivities for our various layers here? So when we come back, we'll shift gears and we'll take a look at some of our material sources as we did previously.